Okay, so welcome back, everyone. As I was asking earlier, right? Any of you have any questions before we can move forward with this today's session? If you don't have a question, then I will start asking questions. Okay, so I think we in last 2 days we have in last two sessions actually we have covered quite a lot. We have started with how AWS Analytics vertically divided into multiple verticals, like which is streaming, big data, uh, your search, BI, right, and then advanced analytics. Apart from that, we have also learned how different services put into those different buckets. Like for the streaming, we have a Kinesis and a Kafka. For search, we have an Open Search. For the BI, we have a QuickSight. For the big data, we have EMR, AWS, Glue, etc., etc. And then we started with learning what is the big data. So why can't one of you, help me to help group to explain what's the big data really quick, just one or two line. Yeah, it's like literally if you go for an interview, they will ask this question. So you should be confident enough to answer, at least to me. No one responding.
Is it like a huge data set with a different set of data, like a structured, unstructured data?
Yeah, it's a one way of defining it.
I'm sorry?
I said like yeah, it's a one way of defining it. Yes, you can say that it's a big data, but technically what we have learned in our class is any data which is not able to accommodate in terms of storage, and compute to a specific systems are a big data. For instance, if we have a laptop or we only have a laptop to store data, and my laptop has only 1 terabyte of capacity to store the data, and only 4 GB and 16 4 core and 16 GB RAM. If I put like five, try to put like 2 terabyte of data on this one, or even a 1 terabyte data to process all the data, this 1 terabyte data is going to be a big data for my laptop. Whereas if I have a big system where I have, I don't know, maybe storage of 20 terabyte of capacity, and I'm easily able to process that 1 terabyte of data in my system, that may not be the big data for that particular system. But in general, in a layman language, any data which has a high in volume, and then it's in different veracity, and it's in different volume, which is coming in structure and structure. That is been defined as a big data. Okay, so once we had an understanding around big data, then we have talked around, okay, what's the challenges, right? Why we have what happened or evolution of the big data. So we started with SDFS. We started with learning how, we used to have a processes called SDFS, so we can have the data being distributed across multiple places, and it's used to process that. And then we have eventually moved into cloud solution. We started calling it uh, data lake, right? And then in a data lake, so yeah, so before I can move, so what's the definition of a data lake in general, if any of you? Maybe Apurva, why can't you just take a tip here? What do you think? What's the data lake is?
Yeah, it is the platform where you can store structured, unstructured, or semi-structured data.
Hmm. Okay, this is one. There are other characteristics of big data or data lake. What are those? Raghav? Yes.
Data lakes primarily are, they have like a wide variety of data sources inside.
Yeah, that is one. Yes.
They also have, they can also use from they can also use semi-structured, structured, and unstructured data.
Yeah, that's the white. Yeah, that is there as well. Yeah.
And they can also allow you to use a lot of different analytics as a part of them, and
Okay.
provide big data capabilities as well.
Okay. You're still missing two very important ones, which is being as an interviewer, I'm looking to, or I will look to see if you are able to provide those or not in your definition. Anyone
So
else?
I think we store the data as it is, like no, not in more modified form. Like say, if I have CSV, just I can store it in a CSV, still
Mm-hmm.
analyze it, right? It's more of native format. I can store it
Mm-hmm.
and um, just put it wherever it is. Like no, still I can analyze it in a central place.
Mm-hmm.
I think we don't require a predefined schema structure
Mm-hmm.
data lakes.
Mm-hmm. Okay. What else we are missing? So guys, we this is like you are missing the very basic concept of the data lake. And as an interviewer, if I'm not able to hear those, and trust me, I took interviews. So I will not let you let you join or let you pass that around is decoupling of storage and compute. I can literally go ahead and start talk about all the good thing about Athena in our this today's session. But if you do not have a basic understanding what we have learned in past session, then it's like not making sense me to put much more much more knowledge in a table if we are not able to recollect the previous one, right? So I will highly request go and after the session just spend 1 hour to look for these videos. Okay, so you all spending your 1 hour of time in this morning, right? Me spending this 1 hour of time this morning, and it's important. And as many of you have posted in that survey we had, okay, I'm a beginner, and most of you are looking to have a either looking to transition to new career, or you wanna do better in the career, or wanna learn about analytics, right? So this is important to understand. So that's what I'm trying to emphasize is like, hey, you should be kind of, even when I'm giving this sessions, you should be, I will be also helping you to prepare for interview. So let's say if you're going for interview, this other question being asked, like, hey, can you help me to understand the big data even before going on a deep, right? Or what's the why we have moved to the data lake in very first place, right? So that's where you will be explaining this two concept is important. Decup schema on a read, and the decoupling of of storage and compute. And what specific problem is solving this one here is we used to have a databases and data warehouse where we used to store our data, but when we had when the data exploded, we start collecting the data from all the different data sources, right? We need to have a place where we can have all the data being stored without being worrying about how we able to process the data, how much compute could we going to need that to process those data in a few, right, to process those data. That's where like the data lakes comes into picture, where we have an object store like S3, right, or Azure Vault, or Google Storage, where it allow you to store all kind of a data without you being worrying about how much processing power. When I say processing power, it means I'm talking about memory and vCPU and memory, right? So it allow you to store all kind of a data without you being worrying about vCPU and memory in very first place itself. Other important part is like, schema on a read. So when you're building your data lake, so you have not to worry about creating the schema upfront. You have your schema upfront, like, you're just building your pipeline and just dumping the data. I will be just reading the data and dumping the data as it is. So what it will offer is, it will be like, speeding up your ETL process or ELT process, like, extract, load, and then later you have to worry about transforming the data, right? So this phenomena of moving from ETL to ELT, that's what, like, here I have, as a business, I have not to worry about how the schema look like, how the structure of data look like. That is I can think of that later. Let's have the data kind of brought in and have been stored into the data lake. Make sense? Are we
Yes.
are we
Yes.
on these two important topics of characteristics of the data lake? The rest of that, those are fine. Hey, I will able to store any kind of data structure, semi-structure. So those are there in everywhere. You can go and read on internet, you find those things. But if you not have the basic understanding why we have brought the data lake in very first place itself, why we calling in data lake, right? Was that important characteristic, then you're not able to differentiate yourself to other candidate when you're going for an interview, because everyone is just going and reading the same definition what you have just told me, like, literally, hey, we have this different varieties of data being stored, different kind of a data being stored, and for the future, etc., etc. Those are nice, but you should be starting with this too. Hey, we had this problem. That's problem being solved by the data lake, by decoupling the storage and compute. We had this problem. This problem being solved by the data lake to, have a schema on a read. Okay. So in a last call or a last session when we have started with a use case. Okay. Anyone help me to understand what was the use case? Okay, so the use case was, we had this CSV file. Okay, and now the ask was, hey, how I'm able to go and perform an analysis against this CSV file. Okay, so then this is your data source. Thereafter, we had this storage layer, right? So storage layer, we had this mm, S3 bucket. Okay, and once we had this S3 bucket, thereafter we wanted to see how we able to analyze our data. So we had this Athena. So this is what we're going to. So this is the simplest use case you can think of. Hey, I'm a business analyst. I have a bunch of file which I have received from XYZ places, maybe from external vendor, maybe from different teams, maybe from the sales, maybe from the HR, maybe from marketing, etc. Right? I have these files. Now I have to perform the analysis. How am I able to do that within in a data lake space, or sorry, in a cloud space? Like, okay, how the pipeline going to look like? Okay, so we will be starting with a simple use case, and then we try to understand what all components being involved in this use case. So the first component is, like, as we are building the data lake, which is in S3, right? So I will be touching this data lake. When you build in data lake in S3, what all things are there, how you define the data lake, right? What's the structure of the data lake look like? And thereafter, once done, we will be going and learning about Athena. Okay. So I will be just quickly, because we have already spent too much time on the data lake. I will be just very specific. I'm not talking about the data lake in general. I'm just very talking about specific to S3, how you define the data lake in S3. Okay. Anyone can tell me, like, okay, what all different layers are we have within the data lake? Any idea?
You mean like a storage? You're talking about like a
Different layers. So when we talk about data lake, right? Someone before we have started our session, someone has mentioned few different, like, okay, you able to broad the data as it is, right? So when we bring the data as it is, we are calling it raw layer. Okay. In this layer, your data is in raw form, or as it is. So you're bringing the data from the CSV file, or you're bringing the data from, let's say, databases. You're bringing the data from IoT devices. You bring the data. You bring the clickstream data, etc., right, from your web application. You are storing the data as it is without making any transform. So that's where that ELT process come into picture. So you must have heard of the term called ETL, which is being very popular in data analytics world. Extract, transform, and load, right? Now we have something called ELT, so which is extract, load, and transform. So I will be going, and so we have something called ETL versus ELT. Okay, so industry is moving from ETL to ELT world, and the idea is, with the evolution of the data lake and so many varieties and velocity and the volume of the data, it's very difficult to make a transformation in very first place of your data itself. The idea is, hey, how I'm able to speed up my ingestion ingestion process. And that's where, hey, without you being worrying about how the transformation of data look like, now we have such a cheap storage being available, right? Let's brought all the data in. And that's where we are having something called raw layer in your data lake, where you will be storing your data as it is. Once the data is being stored in a raw layer, that's where you will be having something called, right, process layer. So you will be processing the data and have the data being stored. So this is like, it has a process data. It means, like, okay, you will be think of dropping null, right? You will be performing all kind of a data wrangling process, dropping null or dropping some column which is not needed. You will be doing encryption, or you will be doing masking against your data, etc., etc. So this is your process layer. And at the end, this it has your consumption layer. Okay, or you can call it like production layer or product layer. So there are different companies and they're calling it n number, but usually it will go with the consumption layer. The idea is, hey, I have processed the data. Now for me to HR to consume, they need the data in very specific format, right? They need the data in this format for maybe the different kind of aggregated table for HR. For the sales, they might have a different requirement, right? From the same set of data, they might have a same different kind of requirement. So you will be performing all kind of a transformation here. So you will be, you have did the extract here from the data source, which is your CSV. You have loaded the data into your raw layer. Once done, then you will be doing all kind of a transformation here. You will be doing all kind of a transformation here, right? And once done, now you have the data being ready in for you to consume. Make sense? So if I have to define three different layers on, let me do a recap. So three different layer is your raw layer, curated, and consumption. Okay.
Now, need one question.
Mhm.
Uh, if we are taking data from data lake
Mm.
and we want to do analysis,
Mhm.
then we are taking directly from consumption layer or from processing layer.
Okay. So you can call it so different. It depends, right? So if I'm a data engineer, right?
Mm-hmm.
My ask is to transform the data. Then I will be reading the data and making transformation and then putting the data into curated or consumption layer. But if I'm a business analyst, if I have to perform just analysis against the data, right?
Mm-hmm.
That's why I will be taking the data from the consumption layer and start, because consumption layer is the pure think of this is the purest form of the data, which is like, okay, the data as it is, and this is a most optimized form of the data, okay, for your analysis.
Yeah,
So
understood.
so here is like I have did all the cleaning and cleansing of the data. I have stored the data in a way it should be optimal for my tool to read, right? uh,
Mm-hmm.
those like I will be talking in general, like when we start having the session around the cleanup, glue, I will talking like, okay, how your data will be getting stored in an optimized way, or how you're able to perform those, like, make changes, and then I will show that example as well. But the answer to your question, usually if you're an analyst,
Mm-hmm.
you will be using the consumption layer for you to perform and for your analysis, okay.
Okay,
Yep.
thank
So we were talking around. So this is again. This is the fourth important uh, topic which we are looking to cover. We have already covered, right? What is big data. The second was what is data lake, right? The third one was the big data, data lake, and we have covered one more. What is it? Yeah, different layer of the data lake, right? And the fourth one is ETL versus ELT. This is in form of when I say like important in terms of like when you go in for interview, you should know this thing. Okay. Um, so we were talking like the different layer of the data lake. I said like, okay, there are n number, like, these three layers of the data lake. This is more kind of a purest form of the data, which is like data as it is. You can say like this will be your single point of truth. This is not optimized for analytics. Okay. you must be asking question, what do you mean by like not optimized for an analytics? So when we say if something is not optimized, you can't create more forms. So maybe I have to create one more board. Anyways, so when someone says like, "Okay, this is not optimized for analytics," it means is the data is not well formatted, right? And it is not. When I say like not well formatted, it means it's like, okay, it has a lot of garbage value. You have not performed any cleansing and cleaning. Okay. Other is like it's not well formatted for the storage. Like, okay, it's not using the right optimal file type for it to store. Maybe the data comes as in CSV, or maybe the data comes as an Excel XML file. Maybe the data comes as an a JSON file, which is being highly structured and sorry, highly unstructured, and or maybe an XML file which has been highly unstructured. So you are not able to able to extract the metadata out of it. It will be just if you look at an XML file, it's very difficult for you to read that XML file, right? It so we have just brought the data in, but we are not yet ready to perform any kind of analysis on the top of the data, like reading the data, how the data look like, making some aggregations against the data, or extracting any business value out of it. Or data is not optimized in terms of how the data is being stored. Like it's not being stored in in an optimal file format. If you have been reading about the big data or a data lake concept, you must be heard of something called columnar file storage, right? Which is like Parquet, ORC, etc. So the Parquet is the most famous file format when we talk about data lake or data analytics in general. And the reason is Parquet has a couple of characteristics. One is it is columnar file store. It means if you're using any distributed computing or any distributed processing, like let's say if you're using Spark, which is again a distributed processing framework. If you're using like uh, Presto, again, if you're using Spark is there, Presto is there. If you're using SDFS or Hadoop, sorry, SDFS is file format, Hadoop is a processing engine. If you're using Hadoop, or if you're using your Trino, right? All these are uh, parallel processing or distributed processing engines. What does it mean is when you try to process the data, it will be. I was not on a video, right? By now. Okay. So I was explaining you the concept. Let me go to the camera. You able to see me or no?
No.
I don't know how the camera gets. Camera is not getting started. So this is strange. Okay. You able to hear me, right? Able to see me, right? Okay. So
Yes.
yeah, I was telling about where I was on yes. So when we say like the columnar kind of a data store, what we're saying is we have this distributed processing engine, right? Which what it do is it actually slice the data into multiple slices and try to process the data into multiple chunks, right? Have you heard of term called map reduce?
Yes.
Okay. So the idea is like, okay, you will be having your data being stored into, into multiple, your data being distributed into multiple chunks, and then you will be processing the data. So let's say, I can give you an example here. Okay. So I have to do a word count, and I have this paragraph. I have this entire page, right? And I have this multiple paragraph. I'm just giving an example, right? So when we talk about a distributed processing, what the distributed processing do is it will be dividing your processing into multiple paragraphs. Okay, so it's mapping here. What the process is happening is map. So I have this one paragraph which has bunch of words in it. I have second paragraph, paragraph two. Here, this is paragraph one. This is paragraph three. This is paragraph four. So I have divided this into multiple churn, and I have this processes like let's say I will be using Spark, I will be using Hadoop or anything as such, right? So technically, I have different processes. One process is reading only this much of data. Other process is reading this much of data. This process is reading this much of data, and the fourth, right? So this one is created sets of a maybe I will be, let's say, let me give with my example. This paragraph has an update in 4 times, right? Maybe this paragraph has an update here as well, maybe 2 times. This paragraph has an update 5 times, and this paragraph has an update 1 time, right? So now all the processes has been done. Now what I need to do is I have to reduce, right? For me to kind of combine. So if I'm doing a word count, I have to have all the numbers could be sum out, right? That's the process of having the reduce. So you will be kind of combining all this data. And once we doing is we are doing some kind of a shuffling. Now we are moving the data from multiple multiple think of these are the processes, right? This processes one holding this data, process two holding this data, process three holding this data, process four is holding this data. So we are doing a shuffling, and once done we will be having my name 4 to 6 6 7 7 5 12. So I will be having at the end Navneet as in 12, okay, as a result. So this is the three process. We have this map where we have read the count of the each word, and then now we are looking to do a detections where like, okay, I wanted to have this summation of the data, like how many word count is there. In order for me to do that, I will be doing a shuffling. Maybe some processes do not require shuffling. Maybe some other name. I don't know. Maybe XYZ, it has only 4 data in it, right? Where XYZ is null here or 0 here, XYZ is 0 here, or XYZ is 0 here. It means it has no data of XYZ. So in this case, there is no such called shuffling. I only have that data being reduced, and then I will be have the data being applied, and then Navneet is 12, XYZ is 4. Why I'm explaining this concept is because when you talk about the distributed processing, this is how usually most of the distributed processing works, where it try to process the data in parallel, and once that is being done, it try to combine the data together, and once it will done, it recommends in order for it to have the data being presented as an output as in reduced form, that it will be doing the shuffling. Okay. So this map, shuffling, and reduce, you will be hearing this many times when you talk about or when you go on uh, map, shuffled, and reduced. Actually, let me put this way. So this is more around how your uh, processing works in a uh, distributed format, right? So we were talking like, okay, how different levels of data stored like in a data lake. We talked around the columnar, why is it, what is it, it is important. So if you have a data stored in think of in CSV, the data is not splittable. All right. So let me open a new tab for this one. Jamboard. So, are we clear on the concept? Any questions? So we have talked through like, okay, we are learning we are learning different optimization around your data lake. Okay, why different layers when we talk around? So we talked around this raw layer, which is not at all optimized, and then we are talking about the curated, right? So we have talked through this, and then we have this processed or consumption plus consumption layer. So we have talked through like, okay, how you're looking to have the data being optimized and being so how you want to have the data being stored into more optimized file format like Parquet, ORC, etc. Right. So why? Because one very important characteristic is it is a Parquet when we talk about or when we talk about ORC, right? These are the file in splittable in nature. Remember, we have just covered this concept here. So this is very important because if the file is not splittable in nature, my process is not able to do a parallel processing. This is why it is important to have file in splittable in nature, right? So Parquet and ORC are the file which is being supported. Whereas when you are having the file is in CSV or a JSON, and within the JSON itself, if it's a it is a think of a single line delimited, right? uh, File that is maybe that's splittable in nature, whereas like if you have a single JSON file that is not splittable in nature. Okay, so how the data is being stored in the JSON is different, but in general, if we have to learn, these are non-splittable file. And once I will be going into thin, I will be showcasing why it is, how the difference is. So when you have a file which is not splittable in nature, it means is it takes a lot of time to process the data. So there going to be only one process that will be reading that entire file. It will be not dividing those file into multiple chunks, right? So this way it will be taking a lot of time to it's not very optimized for these files are not very optimized for analytics. So whenever we are building any pipeline, so the idea is how be able to convert those files which are not optimized to uh, to like optimize for analytics, right? So as a data engineer or a data steward, your first job will be ensuring your data is optimized for analytics, and it is important, especially on the cloud world where you will be pay as you go. Like so, or more like if the file is not optimized for analytics, I will be paying more to process that file. I will be paying more to have the file being stored. I will be paying more to run a query against it. So my first task will be how I will be converting the file. So the task is, hey, I brought the data from data source. Let's say if the bring me the file is from the CSV, I have stored my data. Mm, this is so I have stored my data in a data lake, that is S3 in our case. And once done, now we will be looking to do a transformation. One transformation will be converting this CSV file into Parquet file. Okay, so you will be building an ETL pipeline where you will be reading bunch of CSV file and then converting those into Parquet file. That is one transformation. So when we talk about different layer, so within the storage layer itself, you have this raw layer where the file which came in, and then this is your transform layer where you have converted the file into Parquet file. Other important thing is when we talk about optimize and not optimize file format for analytics, or optimize and non-optimized way to do an analytics, is one is we have learned just is file format, how file format is important. Other one is something called data partitioning. Okay, have you guys heard of this term data partitioning? Or are you aware of what the data partitioning is?
I'm not sure, but is it the same which we used in Python or SQL, the partitions of data while analyzing?
Yes.
We use partition by function. So is that the same, or this is different?
The partition by functions is a windowing functions, right? Yes. This is where we primarily more around how the data being stored, or how the data is being stored within the data lake, right? But in theory, you can say yes, like okay, partitioning the data is like structuring the data in a different groups. Okay, so when we talk about data is not being partitioned, think of like, hey, in a raw layer, when I brought the data, let's say I'm an e-commerce organization. Okay, like for instance, my company Amazon, they are e-commerce organization. So they have stores all everywhere. Okay, I have built the data where I have put all the data from like let's say North America, or maybe just say that let's go with the region itself. So within the North America, right? Then I have or maybe let me go with uh, with hmm, countries first. So let's say I have the data brought in to from uh, USA, okay, Canada, or let's Mexico, and then I have the data brought in from the Brazil, right, or 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 other not like South American countries. I'm not able to recollect many. Uh, Thereafter, I have the data brought in from Europe, maybe London or sorry UK, and then we have from France, Then we have the data from your Middle Eastern countries. Let's say UAE. You have data from India. You have data from let's say Bangladesh, etc., etc. Right? So this is like, okay, I have this e-commerce company where I'm bringing the data from different countries. Like this is my sales data. So I have brought all the data as it is from different companies. But let's say if I have to perform a analysis where, hey, can you give me you know, country over country sales number, right? So if I have a bunch of data just being like, you know, all the data has all the country name, right? It's going to be super difficult for me to perform an analysis. So what I'm looking to do is every time when I have to do a performance analysis, I have to look for this file, look for this file. Let's say if I have to give the sales number of USA, right? So I have to look for this file and see if it has a USA file, if it has a Canada file, if it has a, like, you know, even Canada has a USA data, Mexico has a USA data, etc., etc. So if I'm bringing the file as it is, right? So I will every time if I have to give the sales data, I have to read all the files. So my first ask will be how I'm able to organize the data in a way. Just one second, my kid is. Yeah, I just. Okay. Anyway, so I was telling earlier, like, okay, if we have a, like, if I have to just give you the sales number of the candidate, right? I have to go and analyze all the file and ensure none of this file have a sorry, file the sales number of your sales. So I have to go through all the files and I have to analyze none of these files has a USA data, okay, or USA sales number. If I'm just bringing the data as it is. So the next ask will be how I may be able to store this data in a way. If I have to do a sales number, I will be only looking for a sales file. So this is where we will be doing. Let's say if I'm doing a partition by country. So what I'm doing is within my data, uh, mm, within my S3 itself. Let's say this is S3 raw layer, which is has all the file as it is. When I'm storing my data in here, I will be saying, hey, country is equal to USA, right? And then country is equal to Canada. Country is equal to India. So this is like I will be doing a partition by country. Okay, so this is my partition column. So the ask is like, hey, if I have to give the sales number of USA, just I have to read only this file or this folder. I have not to go through the other folders. So this way, my scan will be reduced only to this particular column. Okay, so this is more on the partitioning. And once we start learning around glue, once we start learning around Athena, right? I wanted to have Athena session being started here, but like every time I just start covering something different. So which is important for you to have your fundamentals built even before when you go and start learning about AWS Analytics services. So your data is being stored in this partition. Okay, so you can have a partition by date. Let's say if you're running a query where you will be saying, hey, give me all the sales of USA between so and so, right? So you have stored your data between as a partition, one partition you have created as USA. Maybe within that you will be able to create one more partition, call it date, where date is maybe today's June 4th, 2020. So if I have to get the USA data for June, then it only look for this particular folder, and within that particular folder, it will only look for this particular folder. Okay. So what we're technically doing is we are we are making our system intelligent enough, or in a way means we are making our storage optimized enough for our processing power, processing engine, so it can only look for that particular folder, not that mm, uh, entire structure. Okay, maybe I can go and give you an example here. Or I think I have did that showed this example in past as well, right? So let me quickly stop sharing for a second, and then let me spin up my lecture. Any questions by the time I will be spinning up my AWS account or logging into my AWS account? Okay, there's no sense going to so you're able to see the screen here, right?
Yeah, we can see
Yes.
that.
Okay. So if I go into Athena, and before even going into Athena, ask is like, okay, how the data is being structured in a way I will able to review the data, right? So if I have to take so I have to create this database. I don't think I have created this database, but let me go into some different accounts here. Written- Okay. So if you see here, right, I talked around a couple of important concept. Why it is important to have your data being. You guys able to see my screen here, right?
Yes.
Okay. So a couple of concepts we have. Let me kind of zoom in so this way it will be better for you to look. So we have talked about why it is to have the data being stored in a better file format. So this is my CSV, which is similar to CSV, which is this is only a tab delimiter file, whereas other is other is Parquet file, right? So I said like I told you, right, the first task you should be doing is to have those file format is being your data being optimized for this very specific file format. So if I just simply go and review the table here, it will be giving me this US data. But if I just simply go and run a count against this data set, like okay, this data set is Parquet, which is an optimized for analytics, whereas this data set is in CSV. This is not very optimized for analytics. So I'm running this select statement here in parallel. Let me run other select statement from Parquet, right? So this is Parquet. If I just simply go count start here, and this is my Athena. This is my Parquet. So if I just simply go and run start here, right? Count start here. So I will be running this query here in this for Parquet. Similarly, I will be running the query for CSV file format, right? So if you look here, it's scanning the data. It's going through the entire data set. It has a 32 GB of file. Whereas what happens with this one? Type it with length. Market. Oh, uh, remember we had a made a change last time when we were showcasing that example of schema on a read. So let me generate this PDF here. String of character, not the character. Should be string. Okay, now if I go and run this as a public demo, if I running this one here, just look at like, okay, I have star partition. Okay, I have to load the partition here. Demo. Okay, with that, I'm just here. Okay. So if you see here, I just ran this query and I got this 160 million record. Sorry, 1326, yeah, 160 million record with literally no time, right? Whereas if I go here in a CSV, my job took 1 minute 10 seconds just to present this result, and the reason being this job is running against the CSV file, right? If you see here, this is the CSV file. I think kind of 51 for us, so this will be able to come there. So this is a CSV file, which is again a tab delimited file similar to CSV file. And if I'm running against it, it has to go through the entire scanning. And whereas when we have a Parquet, what it did, Parquet did is, mm, it scanned the data, and if you see here, it has not performed any scanning at all. And when I was saying like Parquet is an optimized for data, it's because Parquet itself contain that metadata information around your data. So if I have to, other important task is, if we have this data being partitioned with let's say if I have partitioned this data with using product category, right? So let me quickly run a select bar of this data here. 10. So let's say this product category gift card. Okay, so I will be saying give me count of all the gift card, right? And then I will be saying profile. So if I just running this here, right? I just sorry, count up all the product, count up all the product categories. So if I'm just running like, okay, hey, can you give me a count of all the product categories against this one here? And similarly, if I just simply go and run same thing here, but I will be changing this data set to PHP. Okay, so this is I'm running against the CSV kind of file format here. But if I'm running the same task in here with PSP, let me run this here. This query is still this query is executing here, and let's just go this here, and I'm running this again Parquet data okay, as well. This query is running as well. So just look here how fast this is. Like literally, it just gave me data in in a fraction of seconds, right? I got the data in 1.202 seconds. So whereas and it has 160 million records in it, and whereas when I'm running against the CSV file format or TSV file format, which is same as I mentioned many times, it's still scanning the entire data set, like it's running. It has scanned like this much of data. So every time what is happening, it's scanning the same. So this is what happened here as well. If I'm just think of this is a product data which we have that in the USA, right? So I will be brought the data in here. I have all the data been sitting. So if I'm running against it, this analysis, it has scanning entire data. If I perform a partition, it only looking for this particular partition. So this way it will be making it super fast to run. Okay. And the other thing is, as I said, like it's a skeletable file format. So if I have to do a processing against it, when we're going to learn, like once we start having, in next session, I will be promising I will be going to Athena for sure, because I will be this session is supposed to be for Athena anyway. So but the idea is like you got a sense, right, why it is important to optimize your file format, why it is important to have the data being partitioned, right? So file formatting is super important, data partitioning is super important to understand when you are understanding the concept of the data lake. Okay, why you wanted to have a file in splittable in nature, which is Parquet file or ORC file. Why you wanted to have data in partition, so this way it will be scanning less amount of the data. Okay. So with that, we'll be ending our today's session. Any questions? You guys whatever.
Namita, I've got a quick question. So when you were querying on the Parquet file, so does that mean that you can directly query on the file itself, and we don't have to convert it into any table form?
No, that's the idea of having a schema on a read, right? So I will be so the decoupling of storage and compute. Remember, we learned that concept earlier. So the idea is I have my data being stored in a data lake itself, and Athena, which is the query engine, which let you directly read the data from your data lake directly, right? So if you have looked at, I'm not sure whether how much attention you have paid earlier, but when I was creating schema here, right? Like let's say if I'm generating the DDL for this one here, this is the definition. If you look at the definition, this is where my data is stored. This is just a bunch of S3 file. Let me go back and show you. So this is my S3 bucket. This is where my data being stored. So if I go and S3 location, so you have not to store data in any database. That's the idea of having the data lake, right? So you will be having the data being stored here in this bucket, and so this is where I have this PHP data as it is. I see there are a number of files in here. You're able to simply go and read this file. Let's say if I am going into, I don't know, maybe I can go with some small file, 63 MB. I will be going in, and if I just do a S3 select here, delimited this tab because it's a tab delimited file. And if I just simply run a query, the file is a little bigger than expected. Let me find some smaller file. Let's see this one. But the idea is like, you have your different file being stored here, and you will be able to read those files from your. So if you see here, right, this is my CSV file. This is how my data being stored, and then I have created the schema there with using a cleaner, and I'm able to read the file. But under the hood, this is how my file being stored. Similarly, for the Parquet, I have the data being stored where I said like, okay, these are the product column. So if you see here, if you go back to Athena, there was a column called product category, right? So I have partitioned the data with the product category. So this product category apparel, it has all the data from the apparel, and the data being stored in a Parquet file format with a snappy compression on it. I have not covered the concept of compression. Maybe I will be covering the later part, but the idea is that we'll be having the data being compressed. But primarily, maybe the two important thing is like how your data being stored, like the file format. Other is if the data is big partition. So these are the two very important concepts you should remember when you talk about the data lake. Okay, optimizing your data lake. Make sense?
Yes.
Yeah. Okay. So having said that, this is like end of our presentation. So a couple of requests. Let's say, yeah. So if do review the session. It is important to spend few hours if you're really looking to learn, and this will help you in your interview in a big way. Other thing is, if you have not made a donation, again, like this is what I'm doing is for a charitable cause. So I will request you to make a donation to the Vedic Mandir, Hindu Vedic Mandir Go to Fund. I will, if you don't know where to go and donate it, like, we have this fundraising which is happening, simply go and you can make a donation here. I really appreciate it. Yeah, so having said that, we look forward to see you for next session. And if you have any questions in between, feel free to ping me, ask me, or DM me, etc. Okay. Thanks everyone. Take care.